Alright guys, I have solutions for number 8 and 9 for the 6.8 worksheet. So number 8 says using the enthalpy of formation values from the appendix in your textbook, calculate the enthalpy of combustion, delta H combustion, for 1 mole of C2H2 at 25 degrees Celsius, which is again standard conditions. So for number 8, I'm again just solving for delta H. So there's no going, I'm not going to have like an X to solve for, is basically what I'm saying. And I'm going to set that equal to the sum of the heat of formation of our products, which based on stoichiometric coefficients, we have 2 times the heat of formation of CO2, which is negative 393.5 kilojoules per mole, plus 1 times the heat of formation for water, which is negative 285.83 kilojoules per mole. And from that, I am subtracting the heat of formation of our reactants, which is going to be, what's the coefficient for? The coefficient of oxygen, which is 1.5. It doesn't really matter because heat of formation for O2 gas is going to be 0, plus the heat of formation for C2H2, which is a positive value of 226.77 kilojoules per mole. If I plug that into my calculator, I get a delta H value of negative 2,816.0 kilojoules per mole. For number 9, I think part of the problem was probably that the back of the textbook doesn't have the enthalpy of formation for 1 mole of glucose gas, only glucose solid. So since it wasn't in our textbook, I just plugged it into the Google, and I got a heat of formation of negative 1,260. So no, it wasn't in the back of your textbook, but usually Google is pretty cool. If it was on the AP test, they would be sure to give it to you if you needed it. So no worries there. But you may have used the heat of formation of glucose solid, which could have gotten you a different answer, which is why you would get it wrong. So for this one, we're again solving for our delta H. This time, heat of formation for our products is going to be 6 times the delta H for CO2, which is again negative 393.5 kilojoules per mole, plus 6 times the heat of formation of water, which is negative 285.83 kilojoules per mole. And then from that, I'm subtracting the heat of formation of O2 times its coefficient, so 6 times 0, which is 0, plus the heat of formation of that glucose gas, which again is negative 1,260 kilojoules per mole. And again, I just found that off of Google because the back of our textbook did not have it. If I plug this into our calculator, we get a value of negative 2,816.0 kilojoules per mole. Okay, so that is number 8 and 9. Let me know if you come up with more questions on those worksheets. Happy to make a video for you for those solutions. Have a great day.